Without further ado, I'm going to give the floor to her, and we can get started.
Okay. Oh, yeah, it's working, the microphone. So we will start, and I will introduce myself before. Maybe many one of you don't know me. I am from Guatemala. I travel for Drake and Boston, so I live there and work there. And I am community leader of two communities, one Google community that is Devs Plus 502, and I am leader in a JDuchess chapter that are the Java community's female chapters that we all focus on increased participation of women and make to the young ladies, when they become women, choose technology careers. And I was member too of a Java users group, and actually I am CTO in a startup called Productivity, and I am an Auth0 Ambassador Technology and an Oracle Developer Champion. So we will start with the talk, and before to say how we can improve security in Android, I want to tell you that to you. Security is a team effort, so it's not only responsibility of the Android application or our backend. If not, we need to make a combined work between the two of them. So I will tell you a little bit of stories, and I will take two technical things. So I will start with one story that is I call free hamburgers. So what happened? You know, once upon a time in a far, far, far away lands, started a new restaurant of hamburgers. In Guatemala, people really likes a lot McDonald's or Burger King. We don't have a really high culture of hamburgers like here in United States. So someone created this restaurant for sale, especially hamburgers. And the restaurant was really successful, so they created a loyalty app. So in the loyalty app, it's really easy, right? We accumulate points, and then when we can have a lot of points, we can redeem that for a free hamburger or whatever. So what could go wrong here? Someone had an idea or something? Free hamburgers, yeah, exactly, but so, yeah. Well, loyalty programmings are marketing strategies. So usually, basically, I am paying my hamburger after buy 10 hamburgers. But this company start to lose money with the loyalty program. So what could go wrong there? Someone have an idea of that? Yeah, you can catch points without that. But, well, I will show you that. This is the most basic issue in security. And it usually happens when we are a beginner and we don't investigate anything. But the guys create an API, a RESTful API, expose it in that way. So what is wrong here? The first thing is that they use params. So we were consuming our URLs and sending everything in params. So I can send the user and the code there. The next thing that was wrong here is that they use get method for consume the RESTful API. So when I am using get, if someone is monitoring the Wi-Fi network when I am connected, they can show the URL with all the params there. And finally, they didn't use an SL or TLS certified. So that means that anything of this information was traveling encrypted. So these people discovered that issue because they was losing money because we can show the code to any restaurant. I discovered this issue not because I was part of the solution. If not, one friend of mine is of those freaky hackers that is monitoring networks in, commercials and those things, and he noticed that. So we changed free hamburgers, by the way. So he said, oh, any restaurant have a single code. So I just need one code of one restaurant for can put in my app and change. So I collect 10 points, and when I collect 100, I can change for one hamburger. So what we can do for fix that? So here the problem is not only the codes for the free hamburgers. So if someone was pending of that, can catch emails and passwords. What happened when we expose emails and passwords is that usually users always use the same email and try to use the same password because it's easy to remember instead to have many passwords for many accounts. So it's a problem, right? So the solution is you can do at least 2 of those things. That is, use a different HTTP method, that is the POST one, for don't expose the params, and use the SSL and or TLS certified for sending encrypted that information. I suggest to use an exchange protocol that is more easy to manage too. So we will see this. We now will have a post, and so the people that is monitoring the Wi-Fi only will watch this URL, but never will have access to the information that I am sending there. So this is the first one. And if you use the TLS or SL certified, this information indeed will travel encrypted. The next thing is that human verification. This is something new. You know, Google launched it last year that we can use the reCAPTCHA application for Android applications. So this is really simple. That's why I will show you in a few steps how you can add that to an Android application. So the first thing is that we need to register ourselves in the reCAPTCHA admin. So I create like the project. They call that a web. And I choose that I will have an Android. I put the name. And I put the packages when I want to use this API. That will generate to me something that everybody says that is important is read the terms of services that usually we only say accept. Okay? And this will create to you a side key and a secret key. This side key is the one that we will use in our implementation. And in that, they put to you the snippet of code that you need to copy and paste in your application for use. And they gently put there the key too, for you don't forget that. So one other important thing is add your dependency. So, you know, copy the code will not make everything work, so we need to add the dependency. I was investigating, for example, 4 or 5 months ago, we need to add 4 dependencies. Right now, we don't need these 4 dependencies, so if you found one tutorial that says that, is obsolete. And this is the code of my snippet. You only need to put that. In the past, we need to add to the Google API client, so now it's not anymore necessary. And this only makes that we can run the reCAPTCHA, and that validate to us in the reCAPTCHA system in the server. But we need to add here, for example, I am logging here my token result, but after that, I need to verify in the website or in the REST API that my process of reCAPTCHA was successful. I will show you that. So my app, this app looks like that. I have just a button, and I will press that one. In this case, is when I will eject an action. So I will verify that. And the same app will be verified that we are not a robot. So here is in Spanish, but say we are verifying that you are not a robot. And I didn't make a programming the verification with the server, but I use an application that is called Insomnia for test RESTful services. So here is the URL of the API service that is site verify for verify if the reCAPTCHA process was correct. I need to send my secret and the token, the response token that I received. And exists a third param that I didn't use because it's optional, that is send the IP that we use. And here they return me that was false. And it's for one reason. And that happened to me all the time, and I don't know if it happened to someone else, but I always forgot add my internet permission when I am making a demo or a test of something. So when I saw that, the first key was timeout. I say, okay, yeah, I forgot again the internet, so don't forget that. And here have my successful. So when I add the internet, I run again. I'm pushing my reCAPTCHA button, and I have a successful response. So I need to verify that. And if this is successful, I can continue with my process in my application. If not, the idea is that you don't do that because it can be a bot or something that is not human trying to access to this function. The next thing is a history that happened here in United States. I don't know if you know about that. I call that convenience over security. And this is for all the things that what moved But this is a case of a Starbucks that was at the end of 2014. So what made these people of a Starbucks? They have an application when you can browse coffee and those things, and you put your credit card, and everything is okay, right? So someone detected that these guys of a Starbucks was saving usernames, passwords, and indeed geolocation information in a plain text in a file with public access to everybody in your app. It's like when you save, someone sends you through WhatsApp an image, and you can see that one in the gallery. Something like that happened with these guys of a Starbucks. So anyone with access to your cell phone can check this file and have your email, your password, and your geolocation data. This is the public information. So when I say public information, is that what they accepted that was published in this file. But we don't know what other things they have there. So for example, we don't know if they have your credit card number for me that you don't put that again for make a buy in the application. So the problem here is the plain text. So plain text is that mean that if your password is QWERTY, I was watching that is QWERTY, and in public access. So how we can solve this? Well, here we have many levels of things that are wrong since the beginning, that we are saving a username and a password in our cell phone for can send after. But the first thing is that they was saving things in plain text and with public access. So in an Android application, I can make that my information don't be public to other ones. And we have two ways to save information. And the first one is just shared preferences, and the other one is just internal storage, but in private mode. So the first one are shared preferences, and this is the way to create a shared preferences and save something. What is the key here? And I think that we fail sometimes in this aspect because we only make copy-paste, but we don't read what we are copying. And here is the key. If I put that my shared preferences are in private mode, only my application will have access to the information that I am saving there. But if I make a copy-paste to a tutorial that say here that was public, that means that any other application in the cell phone will have access to these shared preferences. So here the important is that I save things in private mode. Then if I am using internal storage, I can create files in that way. When I create a file in this way, it's private, and only my application can have access to that one. The other thing is create files too in a private mode, like we made with shared preferences. The next thing that we can do is encrypt the information that we are saving, right? Indeed, when I am saving that in an internal storage, we have the risk to someone root their cell phone and have access to this information. So Android, since the API version 18, have incorporated all the Java cryptography architecture. So that means that we can create private keys, asymmetric and symmetric. We have a Cipher class for make encryption. Okay, here we have Java cryptography implementation. Most of the keys that I save in the key change is saved in a trust zone in the cell phone. Then we have asymmetric keys from API 18. So we are talking about the algorithms that I cannot spell that, but I know that you understand what I'm trying to say. Yes, yes, you know, always that I call to a call center for say something, I have something wrong. They say, you can spell me your confirmation code, and I start, oh, madam, do you speak Spanish? You know, we can speak to you in Spanish. Oh my God, thank you. Thank you, yes. Okay, then we have the symmetric keys that was incorporated in the API 26, that is Android 6, that is the IAS algorithm and DES algorithms. So here is a chapter of the Cipher and all the algorithms that we have. If our app is supporting Android 4, so we have a really reduced options. There are these ones, the one that I can spell. And the other ones are since API 23. If you can make that in more backward applications like Android 4.0, you can make that manually. I made that in there a long time ago with Android 2.x, so you can implement IAS algorithms, but not in that way. So here, this is a transformation string that is saying which algorithm we will use, the mode, and the padding of that one. And how works this of the cryptography process is that we have the plain data that, by the way, was the one that Starbucks was saving in files. And we will choose an algorithm, a symmetric or symmetric algorithm, and we will create a key. Depends of the algorithm, I only need one secret key, or I will need a combination and a secret private and a public key. And finally, I will obtain a Cipher data that is encrypted information. So here is a simple algorithm. I can encrypt information with a Cipher. So I send the information that I want to encrypt, and I will send my key. I put in the Cipher. I will init that one. I will put that I want that in the encrypt mode with my key, and then I will encrypt the information. And if I want to decrypt, I can use this small snippet. Now came the security myth. That was the justification that had Starbucks in that time. What they say it is better for mobile apps to be easy to use or secure. That was the question. And they say we are making a friendly application because we are permitting a permanent open session, a supposedly permanent open session, versus the security. So the justification was we are saving the username and the password because we don't want to the user make login every time that they will eject a process or make a transaction. But I say this is a myth. This was in 2014. And we have this guy, Auth. I don't know if you listen in sometimes about Auth or never in your life, or yes. In that one, you don't know what it is, but you listening about that, right? So Auth are a security protocol. Establish what steps we will make for the login process and authorization. And this was starting to be cooked in 2006. And the first version, a stable version of the protocol was launched in 2010. So that means that in the time when was this scandal of Starbucks, this protocol exists. So what is the problem here in security? Why we need to send all the time a username and a password for make any transaction? And it's how we are making and designing our RESTful APIs. So we have a client, right? And we have our REST API that is managing our login. But we are making that every transaction that we will make between the client and the REST API require a username and a password. But why? Why I need to make always a login and then a transaction? So what established Auth for don't make that? This is simple. I have a client, and I will have now a Auth server or authentication server, and I will have my backend. So the client, we came to the Auth server, and he will say, okay, I will request a token. That means this is the login. I will send here my username and my password. Banks sometimes have a username and a code and a password, for example. So the authentication server will come and say, okay, these credentials are correct. So I will return to you a token, wherever. We can invent our token. So the client will save this token. And then for every transaction that I will make since now with the backend, I will send this token. And the backend will be asked to the Auth server if this is a valid token. So this is valid, this username or this user have access to the information that want to access in this backend, and he will say yes or no. If he says no, you will return to the user and will say, okay, thanks, but you cannot access to that, or your token is expired and you need to make login again. That depends. So finally, we will return the information to the client once. This is established are the steps. So the idea is that I don't need to make in this process send again the username and the password. So in this case, I don't need to save any more the username and the password in my application, encrypted or decrypted, in the public or in the private. I don't need to take care about that. So what is the really common now? We will talk about this token, this magical token. And I don't know if you're listening talk about JSON Web Tokens. Okay, no, one guy, yes, thank you, other one, yes. Okay, don't worry, I will talk about those ones. So this is an open standard that is, I don't know, it's called Jose. And then the first time that I used that is like, oh my God, this Jose that created this library is so egocentric because put his name in the library, but it's not for that. It's because Jose means JSON object specification, or say JSON object specification standard. So that means Jose. So it's an open source standard that is really stable in the last years. And how looks a JSON Web Token? So JSON Web Token is this. We have a header. We will explore the token, and we have a claim. And this is combined with other part of the standard that is called JSON Web Signature. The idea of a JSON Web Token is that my information travel in some way encrypted, but equals I have access to see this information. But guarantee that anyone can modify the information of this JSON Web Token, I will add a signature. And I can use two different algorithms for create a signature. So I will have a token like this one. I will have my headers, my claims, and my signature. And if I decrypt that, it looks in that way. So I have a header. The headers usually have these two tags. Something that I didn't say is JSON something, because the idea is use the JSON standard for transport information. So I put the algorithm that I use for create my signature, and the type that always is JWT, or what can be JSON Web Encryption too. Here, I am watching all the claims that I am sending. If you see, I don't have here any username or email, for example, and worse, I don't have any password. Something that I saw in other talks when I speak about this is that people believe that now they will send the username and the password in the JSON Web Token, and this is wrong too. So the idea is that you don't send that anymore. So in this case, these guys have this nickname or whatever, and then you can create a small token that represents your user. And other thing that they have, for example, in these scopes is the manage of roles that this user had. Something that happens now is more frequently is, I don't know if you are related with microservices or serverless architecture. This is a good hot trend right now, and basically, this authorization section or part never came to our real backend. We go to a API gateway, and the API gateway made the verification if this token is correct, and if we have permission to consume one service. So never came to the server if don't pass this API gateway. So we need to, this is a good practice, put the permissions that had one user there. And we will talk about the other things, and this is the signature. We never can see what have the signature, but they use the base 64 URL encode for the header, for the payload, this one, and the secret key, all this encrypted. So when we saw, I will show you, or I will continue and show you that after. So we have registered claims for put, are these ones, and two of the most used are the sub one. This sub one is for represent the user that we are, that this token represents. So if you saw in the past one, we have this hunter. So we don't know if this is the real username, if he has an email, but this is the name that represents the user in my system. So in that you can create a hash of the ID in the database that anyone will know that, only you and your system, for send here in the sub. The other one that is common using is the expiration date. So We have two cases here. Don't exist a best practice. In any case, always it depends. But we can have unlimited time tokens. So this is when we have an open session, like Facebook, for example. When I open Facebook, I log in once time, and then I only open the app and always never ask me again to make a login, right? So I am not making a renovation of my token. So those tokens don't have an expiration time. But what happens in a financial application like a bank, for example? We cannot have an open session, permanently, because you don't know if I make mobile applications for bank, and sometimes happen that we maintain and I put that there, and someone else can come and enter to my mobile application and transfer money to him or something like that. Or, well, unless in Guatemala, it's really, you cannot stay in the street, speaking by phone, because someone will steal that to you. So what happens if you open your banking session so that people will have access to that information? So if we have really sensitive information, we need to establish an expiration time for our token. So if someone wants to do something, the application will require to them that make a login again. Well, what problems can solve JSON Web Tokens? All these problems. So we can make authentication, authorization, federated identity in that information exchange. That is especially when I don't care to the people who watch the information, but equals I don't want that anyone can change that one. And then when we manage client-side sessions, that is stateless sessions, this is especially when we are making a front-end development and we want to save the information there. For example, when we have an e-commerce website and I am adding things to my cart, I don't want that anyone put a script or something for add things to my cart. I will save that in a JSON Web Token or save client-side secrets. In this case, we are talking about to manage the authentication and authorization process. So where is the difference between these two ones? And we have this diagram again that is similar to the Auth one. So the first part is the authentication process. That is basically when I make login. So the object is that I consume a post service, my user's login, and I set my username and my password. And I came to the server, and if I have correct these credentials, they will create to me a JSON Web Token with a secret key, with the signature. Sometimes happens that people forgot to put the signature, and if you don't do that, anyone can send you other token, because don't have way to validate that this is a valid token or a token that you really create. And something interesting is that this secret, this key, is only the server knows that key. Our clients never will know that secret key. So, for example, in this case, the Android application never will can validate if this is a valid or not valid token or create a new one. Only the server. So I return this JSON Web Token to my client, and the client will save that one. So we can save that in the private section of shared preferences. And then the next process is the authorization process. So I will send, this is the typical way to do that. I will send my JSON Web Token in the authorization header. So when I came to my server side, the first thing that I will do is validate to this JSON Web Token that is coming in my authorization header is a valid token. So I need to verify to my signature is correct. If my signature is correct, the next thing that I need to do is verify to the entity that represents this JSON Web Token has the correct permissions for access the action that want to access in the server side. If have permissions, so I will eject the process and will respond to him successfully. If not, I will say to him, you cannot access to that, or your session expired and you need to make login again. And this is a website, jwt.io, that if you want to investigate more about JSON Web Tokens. And here you can copy tokens for see what have those tokens. So this is something that happens. So JSON Web Tokens, you can see what have the claims. for that, you don't need to transport any sensitive information there. And if you want to read about all the possible things that you can make with JSON Web Tokens, you can access to this ebook that is really, really good. And don't worry, I will publish this presentation in GitHub at the end of the presentation, and I have there the GitHub, so you don't need to stay taking pictures of everything. So now this is other example that is related with this thing of encrypt information that is called failed encryption. This is a situation that I live in a banking application. So I work with a lot of banks, and sometimes we say, what the fuck are doing they with my money? Yes. Or, my God, it's better save the money like me, our grandpas, you know, in the bed. The problem is the bed don't provide to us credits or credit cards or anything, but it's better saved. So I will don't put a completely JSON Web Token, JSON of banks, but we have something like that, right? Our account name, account number, our balance, and all those things. And the banks, in that way, they have the worst security in the world. They are really paranoid about security. So they say, you know, in that when we route SSL certified of $500 a year, we want that you send this token encrypted. I'll say, okay, perfect, you don't worry. We can do something like that, you know, encrypt this with the IAS encryption algorithm. They say, no, 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 no. We found the best way. And you know what they did? They did that. Okay, yeah, someone laughed. So that means that they catch what is the problem here. So what could go wrong in that? So we have this again, right? So the problem here is that we have the unencrypted and the encrypted information, and someone have access to that. So say, if someone didn't watch what happened here, is like, I don't know if you're listening about that. Reverse engineering. So what happened here? I have the unencrypted and the encrypted values. Why I have the, people don't have access to that, but I have access to an application, and I can show where is the account name and the account number. So I can make reverse engineering with these two things for found where is the encrypted algorithm and where is the secret key, right? Now more with the powerful. Now we have more a process powerful. So I can put a super powerful server for test this and, you know, run a force brute for do that. So what's a bad way to make a encryption? So they didn't want to use an IAS algorithm. So I present to them the JSON Web Encryption that is all the brothers of JSON Web Tokens. This is a little bit more complicated. I have 5 sections, and you cannot take that one and copy in a website like the jwt.io, like I showed to you. And they have a protected headers. We have an encrypted key, initialized vector, zipper text, and authentication tag. And we saw a JSON like this one. So for example, we are here, have the first one that is the key encryption. So we have the algorithm and the encryption. And then, for example, this is all the data that I am sending. So we will don't take more in deeply that one, because if not, we don't end this presentation. So the next thing is identity management. So we saw that is a really crazy thing made that of the login by us. So right now it's really common that we are delegating this task to someone else, especially with these things that I was telling to you, the architecture of microservices and serverless. So we have these guys of Firebase authentication. And what is the coolest part of Firebase authentication? I like this, that we can make anonymous authentication. So for what works that? For example, Amazon. So in Amazon, I don't need to create an account for can watch all the products that they sell, right? But for statistics or something, they need to create a background of what I am watching there. So if we need to make an application that have this same thing, that I need to save what are doing one user, instead when he didn't identify in my system, I can create an anonymous user. So I put a user 155. And I will save all this track of information with him. Then something that happened with Firebase is I only can manage a name, an email, a password, and a picture. And this is all the information that I can have of a user. So if you don't need nothing else, this is okay. They will manage in there the change password, the recovery password, all those things for you. And they have two multiple auth providers, so it's Federated Identity. If someone don't know where is Federated Identity, because I didn't know that 2 years ago, is when we make login with Facebook, Twitter, LinkedIn, and all those guys. And finally now, they added Passwordless. That is when we can make login without using a password. So how many of you joined the Slack group of Drake and Boston? Many of us, or no, you don't, wow. And you are in other group, a Slack group, or don't use Slack, yes? So Slack sent to us the Passwordless in a really good marketing way. They say, oh, your password is so big for write it, don't worry, we will send to you a magic link. This is Passwordless. Made to the people don't enter the password, but offer a second options for make the login. So they are sending now email links, or the phone number is when I receive a code for enter in the application. So the next, guys, is this of Auth0, that they recently, in January, joined the Google partners for make this identity management more focused in Google Cloud and enterprise applications. But sometimes Firebase can come, really small for things that we need to make with users. So they have more options. So we can make a single signing on, that is just put a username and password. And you can make all user management. We can make passwordless. On multi-factor authentication is when we make a login in 2 steps. So I need to enter my username and my password, and I need an extra code that can be sent by email or by cell phone. And they can permit to you make login by fingerprint in the cell phones that have this option. So one interesting thing is that for management, I don't have only a name, an email, a picture, and a password. If not, I can define all the information that I need for a user. The next thing is that I can define roles. I don't know but I have a client. At the beginning, the project was, we will have 3 roles. We have the seller, we have the trainer, and we have the supervisor. Then but sometimes the seller is trainer too. But I don't want to other sellers see what are the trainings that have one seller. The supervisor can be a trainer too. So at the end, we don't have roles. It's that anyone can be everything. So have dynamic roles is something more common now that have a specific roles. Then we have more extensible federated identity. I will show you that, passwordless and multi-factor authentication. And now for go to ending this, the password nightmare. So I will see if you look this situation before. So we enter to a website and we will create an account and we have this for the password. Right, yeah? Yes, this is true. I have one password that I always forgot, and happened the next thing. Wrong password, okay, fuck you. I will change that password, and just save me that. It's like, yeah, right. So for that is that passwordless and federated identity exist. In that don't only happen of us as clients, happen with our customers. I have a system when we remove all security for password. If the people want to put QWERTY, can put QWERTY. They want to put 1, 2, 3, 4, 5, and 6, they can do that. And what happened is that users never remember the password. I cannot enter to the system. Okay, I will restart your password. And I send an email, this is your new password. And I only use letters and numbers. And they say again, I cannot enter. They say wrong username or password. Sometimes happen to the people when copy the password from the email, copy empty spaces. So I make to my backend remove the empty spaces at the beginning, at the end to the password. It doesn't work. People equals cannot enter to the system. So I say to the CEO, you know what? We will implement passwordless. So anyone need to put the password. So how is that work? Is make the magic link by email, or make one-time code via email or via SMS, or if we have access to a fingerprint. And then exist these things that face recognitions too. It's not much common, but we can use that too. And I will show a little bit diagrams from Auth0. So we have a user, and the user will enter, well, the application will request him his email address or his username. So we will send to him the email, and they will call the Passwordless API, and they will send a magic link to this email, so the guy will receive that email. And when I enter to the email, we will make click, and then magically is entered in the application. I think that Slack is a really, really good example. For example, when I change cell phone, I am like in 20 Slack groups, and I only need to put one time that, and he logging me in all the 20 groups, because I have associated all the groups to one email. The next thing is the same steps. So instead to send me a link, they will send me a code. Here are two things. For example, WhatsApp required to verify to the cell phone when I am accessed is the same one of the number that I put. So sometimes the application will need to stay pending to check the messages for take the code, or we need to enter this manually. And then is by fingerprint. So this is something equals, just that we will read the fingerprint. And then we have federated identity. Firebase have this one. We can make the Google, Facebook, Twitter, or GitHub. But what happens when I don't want to use those ones, or I want to use more ones? So sometimes we don't know to these other options exist, but we can use them. So we can use the Auth0. For example, I'm making some system with the Amazon login, especially when I am tracking packages that I brought in Amazon. You say, oh, you can track your package in UPS, and UPS say, okay, you can make login with Amazon. So these have all these guys there. And I will publish this presentation in my GitHub, and this is my Twitter and my fan page. Yeah, in Guatemala, people don't use Twitter, use Facebook, so for that I have fan page. And thank you for coming, and I will stay here if someone wants to ask me something. I will not make that openly, because sometimes happen to the people ask me something, and I don't understand what he's trying to say me, because I am not a native English speaker. So if I speak with you, it's easy to say, you know, I don't know what are you trying to say me. So thank you for coming.